Hello and welcome to the Solve1 YouTube channel. In this video I'm looking at the design of a Raspberry Pi hat designed for robotics. So in the last spot video I created, I did talk about a Raspberry Pi micro hat, this one, designed by Waveshare, that I plugged into my Raspberry Pi 4 in the hope of using it to drive servos in my robot dog micro. It turned out not to work so well for a number of little design reasons, and that got me thinking I should probably design my own. So I did a little bit of research and then put together a list of the things I would like it to support. And that's what this document on the page, on the screen, is showing at the moment. So I want it to conform to the Raspberry Pi Foundation specifications for a hardware attached on top or hat device. The 9 times out of 10, anything I do with a Raspberry Pi in a robot will end up using the I2C bus, and not everything's going to be on our hat. We might have devices out in the field, such as a rangefinder that's I2C connected, or even a secondary MPU6050 somewhere else in the robot. In any case, and on the back of Spot, I have an I2C connected 2-line LCD display. In the case of the LCD 2-line display, it is a 5-volt device. While the PCF8574, which is attached to give it the I2C configuration, will work on 3.3 volts. The specification for the chip says it's designed for 5 volt, and the LCD itself is designed for 5 volt. These things were originally cobbled together for the Arduinos, and the Arduinos is all 5 volt, whereas Raspberry Pi is 3.3 volt. So I wanted to make sure I had a header on my board for running I2C at 5 volt. One of the other things I found was troublesome in the robot dog was the mounting of the MPU6050 inertial measurement unit. Ideally, it needs to be mounted with more than one screw, and it needs to be solidly connected to the robot's framework. And that's something that, the way I've got it in Spot at the moment, doesn't work. In Fred, I have a similar issue with it. It's only really mounted with one screw in his head. So having a hat that has the MPU6050 on it, in addition to anything else, is going to be a major advantage. So one of the big things I wanted to have on was the MPU6050. Because I plan on driving servos with it, and most of our projects do use servos, I did want a PCA9685 on there as well. The other thing is I want the servo power to be very separate to the power for the Raspberry Pi. Servos have motors in them. When motors first start, they will draw significant current, anywhere between 5 and 10 times the rated full load current in most cases. And this can be a fairly significant shock on the power systems. The power system I have in Spot at the moment has the Raspberry Pi with a separate power supply that has a large capacitor on it for surge or sag protection, and that keeps the Raspberry Pi going. When I had it through the Waveshare hat, I kept losing, the voltage would sag enough to reset the MPU6050 and the LCD display on the back. This is not ideal, so I do want to keep those supplies very separate. The biggest problem I find with the robot dog is knowing how much load is on each of my servos, or groups of servos as the case may be. So I have 4 legs, so ideally I'd like to be able to monitor the power being used by each of these servo groups. So for that reason, I want to design it with at least 4 INA219 current sensors as groups of servos. Now, with the addressing that's available on the INA219, you can have up to 16 of them connected to a single item sequence. And that's something to keep in mind for later. But I need a minimum of 4. The other thing that would be nice to have is a couple of ADS1115 4-channel 16-bit analog input devices. These can be handy for Hall effect sensors if you're using them with a compression type setup, as is used in the in-move hand, where the fingertips, when they touch on something, push a magnet closer to the Hall sensor. You can measure the analog voltage on that and get a fair idea as to how much pressure you're applying. The other way of doing that is on the servo mode as well. The other thing that would be nice to have is additional I/O, and for that PCF8574 would be handy. That gives us an extra 8 digital I/O, and they can be used with sensors like the I'm trying to think of the time of flight sensor. I'll look for it later. I know that it has a shutdown pin. They always start on the same address, and if you use that sensor, multiples of that sensor, you can shut them all down except one, fire it up, and then through the I2C bus you change its address to something else, then you select the next one and you repeat the process, giving each one a unique address. So having the extra I/O would be handy for that. And then having capacitive touch sets could also be handy. So in the case of the robot dog, you can put areas of touch so that you can tell when you're trying to pat it. So if you do put the fur over the top, you can pat the dog and you can sense that. You can also put that on robot arms so that if you come in contact with your arm, for example, you put your hand on its arm, it can sense that you've made contact with it. So these are things that are used in various different robots in different ways, and having them all available would be very handy. So with that in mind, I started working on a board, and the first board I started working on was this one. So I think I showed a picture of this one in the last spot video I did, and I gave a bit of a rundown on what I was doing. This board has some serious issues in its design. It doesn't have the analog inputs on it that I wanted, but it covered almost everything else. The other issue with the design is I really should have, on the pins down here, I really should have done that as 2 layers of pins instead of 1. And I could have done the same here, or I could have done, you know, a row of angled pins. Now, one of the things I did find with the program I used to create this board, KiCad, if these pins extend over the side of the PCB, it does treat that as an error in the design rules. Just in case you're interested, this is the back side of that same board. Now, I did find some errors in this board. I did have that this chip up here is actually for an EEPROM, and it's a requirement of the Raspberry Pi specification. It tells the Raspberry Pi on startup what's actually plugged onto it. So if there are any specific bits of code that it has to launch and configure the BCM chip, then that will tell it how to do that. But that's neither here nor there. That it's not a bad design. It's a learning curve for me. So that was my first design. It had the PCA9685, it had the PCF8574, and it had the NPR121. So and the NPU6050 on it. So it had all of those major chips I wanted. I just didn't have any of the analog inputs, and as you can see, there's no spare edges left to put any more on. So I went back to the drawing board and I've started again. So in this case, this is the wiring diagram I've created so far for a new version, and what I'm doing is I'm putting on each section, like each major chip or group, and then I'm putting it onto the PCB, making sure it all fits as I have it on. So one of the things I thought was, if I split it up into two boards and plug one board on top of the other board, plugged on top of the Raspberry Pi, I can actually split all the power sections, like all the servo power sections for monitoring the current flow or that sort of thing, and potentially put a power supply on there with switching capacity to switch the servos on and off independently and switch the power to the Raspberry Pi off independently and all of the sensors. And I could then supply the Raspberry Pi with its high volts so we can run its system, and put a fair amount of capacitors and provision to connect more for sag protection. So to start with, I've created this schematic. This one has the PCA9685 right here. This is our Raspberry Pi header. This one here is the EEPROM that is required for the identity of the board as per the Raspberry Pi specifications for uHAT. And I've also added in an LED here with its dropping resistor on the 3.3 volt line, just to signal that, or indicate that there is power on the board and it's working. Now, down here, I've added in pull-ups and voltage level shifting for the I2C bus. So I have a header connector over here for the I2C, and that's 5 volt tolerant at that point, and we can tap off and get the 3.3 volt tolerant version for our ICs. I'm running the PCA9685 off the 3.3 volt bus because it's ideal. It's a good 3.3 volt chip, and I can then run direct onto the I2C bus. Down here I have the NPU6050. So the NPU6050 is our inertial measurement unit. I've added in this little solder pad here. So it's a solder pad jumper, and when you bridge that solder pad, you actually switch its address to the second address that the NPU6050 will support. Likewise, up here on the PCA9685, I've got a solder pad up here, and that one there is to connect it to a GPIO pin on the Raspberry Pi. So it's actually pin 7. I can't remember the GPIO number, but by turning that GPIO on or off, once you've solder bridged this one, you can then enable or disable the output from the PCA9685. Something I thought that would be very handy to have. At the moment, previously my Robot Lab Raspberry Pi support wasn't really controlling the GPIO pins. There has been updates made. I haven't tested it yet, but it should be able to control it now. If you're running other programs not running inside my Robot Lab, you can probably drive those directly. Okay, so on the other side of the PCA9685, so I've got all of my resistors in here which help protect things, make sure we don't blow stuff up, and I've connected it to a 20 pin IDC type connector, and that will allow me to plug a daughter board onto that point, and then we can have all the power section on there. I can also mount that board elsewhere in the robot and use a ribbon cable to connect to it. At this point in time, it supplies 3.3 volt through it because that'll be required for the INA219 chips, and it also has the I2C bus going through there as well. So this is what I've actually drawn up so far. There's still a lot more work to go on it, but when talking to members of Discord on Saturday night for me, a couple of them suggested that I actually do a video on this. And this is the PCB in KiCad as I've designed it so far. And if I go Alt 3, this is what it looks like rendered as a 3D image. So you can see here I've got the jumper. This is actually required for the chip at the back here. That's the EEPROM. That allows you to jumper it to, normally that chip is write protected. When you short those two pins together, it allows it to be written, and we can update the code in that. I still have to write the code to go into that to program it up eventually. This chip here is the MPU6050, and its various capacitors and resistors around it that are required for it. So that's our inertial measurement unit. This here is our header. Let's see if I can. That's our. Oh, you can turn the components on. That's cool. I hadn't seen that before. This is the back side of the board. As you can see, we've got our connector to plug onto the Raspberry Pi, and I've got these test points on there. Now, this is something else that came out of reading the design guide for the Raspberry Pi hats. They recommend having these pads that pogo pins can connect to when you're testing the board. And I probably need to add in 2 more pads for the ID I2C bus. Only 2 pins I need to worry about. So test pad 1 here is ground, test pad 2 is 3.3 volt, test pad 3 is 5 volt, and test pad 4 is actually the write protect pin. So if you connect TP4 to TP1 as a short, it will actually allow you to write to the EEPROM. And I probably should put in 2 more pins or pads so that the pogo pins can connect and program that EEPROM. Alternatively, you can put a jumper on the board and when you put that jumper on here, it will allow you to program that through the Raspberry Pi. These 2 transistors, those 2 resistors and these 2 resistors form the pull-up and voltage dropping. It's our level shifting for the I2C bus. And right down here we have our LED. Now down here is the PCA9685, and all of the resistors link to this connector, which goes to what will be a daughter board. Now I can probably, with a little bit more work, move that header up a little bit further to give us a little bit more room on the bottom here. And there's still a lot of space left on here for me to put a MPR 121, a couple of ADS 1115s, and probably the PCF 8573. So if these kinds of videos are of interest to you, don't forget to click on like, subscribe, and ring that notification bell so you know when the next one comes out. It also helps the channel a great deal and costs you nothing. If you'd like to become a patron and help support the channel further, there is a link in the description below, and you can join my VIP patron Go Lucky, and my two builder patrons, Elmerals45 and Rightmove. I am planning on building a few of these prototypes, and the support that I've had from my patrons is going to help with that. If you've got any comments or suggestions, either leave a comment in the description or leave a comment below the video, or drop into Discord. There will be a link in the description, and let me know what you think. And that'll do for this video. I will see you next time.